Good morning, Nick.
Good morning, Abdi. How you doing?
Good. I was wondering for the exam, was it like last time where we picked from the two, or do we do every single problem this time around?
Oh, on this one, I think that now I got to pull up the exam actually, which I should have done because I'm a doofus. That is an obvious thing to have had open. Um, the okay, I'm just not going to say anything about that until I've got the exam in front of me, so I'm not lying. Um, so on this exam, so it's actually 9:15. Let's go ahead and start, and we'll start with the question. Um, on the previous exam, there were a couple of problems where you got to pick one out of a set. Um, the one change I made here, because we've got a week, um, is I did actually eliminate that feature of the exam. So in fact, all the problems are do this problem. There aren't any choose two from a set on this exam. I figured since we had um, plenty of time and there'd be opportunities to ask questions, um, I was less concerned about providing you with a quick out if there was a problem that was completely like getting you in trouble. So good question. I should have said something about it. My apologies for not having done so. There aren't any choose your own adventure parts to the exam, um, but you've got time to ask questions and stuff like that. So that's another reason to start early and get in and ask questions here. So I'm happy to spend basically all of today on the exam if people have questions on the exam. um, Office hours, Slack, email, whatever. I'm happy to help out. So that's the dealio there. Does that make sense?
Yes, sir. Thank you.
Not a problem. um, So administrative stuff, exam is due Thursday. Like I said, I figure we'll spend as much of today talking about the exam as people want to. Um, the dojo seems to be kind of a bust post break, um, and I did a little survey on Slack, and the majority opinion there was that that time doesn't work for people. And I don't know why that is. I could easily imagine that that's like when families are having dinner, for example, which might not have been an issue when you were on campus. Um, but for whatever reason, it doesn't seem like too many people can come. So I don't know that that's the best use of everybody's time. Um, so the question, I guess, is do we want to try to find another time that works for people in the evenings and that works for me? Or should I just scrub it and move on? And I'm fine with either way. If anybody has thoughts on the matter now, feel free to share. Um, Otherwise, I probably won't do dojo tomorrow night, unless there's something that happens here to change my mind. Because, like I said, it just doesn't look like too many people can come. So, anybody care? Anybody have thoughts on the matter? Whatever, whatever.
I personally think that we should look for another time.
So, I guess the question is, do we think that? I mean, I guess it's why. Why is that time a problem? Is that a time a problem every night? Um, would moving it earlier on Tuesday make it better? Would pushing it later on Tuesday make it better? So here, let's do the little like you can do the little thumbs up, thumbs down thing, um, and so we'll do sort of a quick poll here. Um, So for how many people, so it's currently at 6:30. We know that does not work for people. Let me check my calendar, make sure I'm not offering something I can't follow through on. Oh, no, not that. So let's look at two other options. We'll look at 5 o'clock and 7:30. So I'm thinking Tuesday night at 5 o'clock or Tuesday night at 7:30. So think for a second, which of those, if either or both, would work for you. And then we'll do a little sort of thumbs up, thumbs down vote on what would work for how many people would 5 o'clock work and how many people. And when I say work, I also mean like you would show up, just knowing you're available, but you're probably never going to show up. Don't bother voting thumbs up on that because, you know, we don't want to like pick a time because a bunch of people were like, I'm free then, not coming, but I'm free then. So if you think you would come, if it was at 5 o'clock on Tuesdays, let's do a little thumbs up now. I see two. I see two thumbs up. Going. Okay. If you think you would be able to make 7:30 and would choose to make 7:30, thumbs up for that. Yawning silence of nothingness. Let's try 8 o'clock just for fun. 8 o'clock on Tuesday nights. Thumbs up. No. So I think evenings do not work well for people. Let me do one last question. Thumbs up if another night would be substantially better and you care. Yawning silence. So I think evenings just don't work for people. And that's fine. I mean, no skin off my nose. But I think that evenings just don't appear to be like the happy place for folks. And so I think we'll have to just decide to let that go. I think one thing I'll do instead is I have a big string of appointment slots on Tuesday. Well, but they're not actually being like booked up at the moment. Oh, and I've got a senior sim, so I can't do that either. Let me. Well, no, I don't know. Yeah, I think let's just let it go. I'm gonna cancel the dojo until further notice. If you have thoughts or ideas on how we might change things so that there's better availability for people, definitely let me know. I would want to be able to try to make things as available as possible. But in the absence of other information, I think we're going to call that a thing. Done. One other question, and then we'll actually talk about the exam and stuff. Right now, there's a set of the last few Chapter 9 problems are scheduled for tomorrow night. And that seemed kind of rational to me last week. I don't know why. It seems less and less rational to me now. I'd rather people were focusing on the exam. So I guess how many people have, so we'll just do a thumbs up thing. How many people have actually like thought about the Chapter 9 Part C problem set? Done any meaningful work on it? Thumbs up. Yawning silence. Okay. Oh, there's like a few. So, but not many. I think I'm going to push that off. I want you to focus on the exam right now, and I think that's what people are doing, and that's probably the smart move. I think I'm just going to push that off to Monday. And that'll let us finish the exam, and we'll then be able to ask questions about it Monday in class, Friday in class, and Monday in class if necessary. So it's currently due April 13th. It'll probably be the next assignment after that will probably be pretty close to it. So don't just completely blow it off. But having it due tomorrow didn't really make a lot of sense. So I have just moved that on Canvas. So that'll be due next week. So we can just focus on the exam. Okie dokie. So are there any questions about the exam?
Could we look over an example of how to like could do like a step-by-step process on how to solve for an identity?
Sure. So to be honest with you, the easiest thing to do is memorize the identities. But if you needed to figure out what an identity was, you could, in many cases, solve for them. So I'm switching to whiteboard here. So what does it mean to be an identity? Identity. X, oh no, actually we'll call it U, because that's I think what the book is using in chapter 8. U is the identity of operator star, and I'll use star because that's also similar to chapter 8. If and only if, so U star X equals X, X star U equals X for all X that the operator can apply to. So if it's a numeric operator, then for all numbers, but we don't have to worry about trees and geese. And so, you know, if you think about plus, for example, 0 plus x is x, and x plus 0 is x. And so x is, or 0 is identity of plus. And then 1 times x is x. So 1 is the identity of multiplication. And true and x is x. So true is the identity of and false or x is x. So false is the identity of or. And then the only other two that are likely to ever come up are that minus infinity max x is x. So for any value is bigger than minus infinity. So the larger of minus infinity and x is always x. And similarly, the smaller of plus infinity and x is always x. So anything smaller than positive infinity. So negative infinity is the identity of max, and positive infinity is identity of min. And that's sort of everything we need to know about like finding identities. I mean, you could find identities for some other operators, but in terms of what's going to come up in the course, that's sort of the whole list. I don't think there will be an identity that we care about that will come up later in the course. Now, I don't know if thinking about it, did I answer the right question or I answer the wrong question?
I was talking more on the lines of like, again, the format of an exam question.
Okay, so like the section C questions.
Right.
So there, I mean, what would be really, let's say we've got, as an example, the sum over x uh, 0 at most x and x less than -2, x squared minus 7. So the central observation here is that this range is empty, because this is false. X can't be less than or equal to 0, and greater than or equal to 0 and less than -2, right? And if you think about it just in terms of like the number line, if this is 0 and this is -2, that didn't work well. -2. The color. This piece here is saying that x has to be out here, and this piece here is saying x has to be down here. And there's no x that's in both of those places at the same time, right? Those two regions don't overlap. So we know x can't make both of those things true at the same time. And so for the purposes of the exam, I'm fine if you were just to say that this is the sum over x false by arithmetic, right? I sort of trust that you can do that level of arithmetic. And then you would use the empty range rule, which is 8 point something small, 8.13. 8.13. 0 is the identity of plus, and then I would just have 0 and I'd be done. And if you wanted to expand this arithmetic, you could say, let's see, let me erase the little right angle thing. Oh, come on, there we go. You could expand this a little bit and say, oh, I'm still in erase mode. That's not good. Go back to drawing. Arithmetic. X can't be greater than or equal to 0 and less than -2 at the same time, right? You could make a little note suggesting you sort of get that why that is going to be false, if that concerns you. If you do something like that, it'd be a little easier to give you extra credit or partial credit. If you seem to have gotten something confused, where if you just are like arithmetic and then you put the wrong thing here, then there's not much to be done. But that's basically the idea. Does that, and if you wanted to draw this little picture, right, you could draw this little picture if that would make sense. I don't know. But does that help?
Yeah, it helps.
Okay. Cool. Other questions?
Yeah, I have a question.
Sure.
So for this portion of the exam, I did like a written out explanation
Okay.
Well, like instead of doing like the proof style, is that
Right.
okay, or do you prefer the?
Uh, that's a fair question. I think, like, if I was being really careful about it, I'm okay with a written out explanation, but it would be good if you, for example, mention Rule 8.13, right? It's sort of crucial for why this works the way that it does. So this only
Yeah,
makes sense because of 8.13. So you probably need to mention, you need to talk about like why the range is false, and you need to mention 8.13, and that whatever this is the identity of that operator, right? I think that information needs to be there in some fashion.
yeah. So is it okay if I like give you an example of my style and like
Well,
I
that would be
applied to this
probably giving
problem?
everybody an answer, which seems unfortunate.
Well, I was gonna put it in like this, like
Oh,
apply
sure,
it to
sure,
this
sure. That would
specific
be fine.
problem.
Yeah, yeah. Go for
So
it.
like, I would say like the value of like summation notation, 0 is less than x and x is less than -2. You know, the whole quantification is 0 as the range is false because there can't be a number between, there
Mm-hmm.
can't be a number that's both less than 0 and -2. And then I say according to the empty range rule, like it's because the range is false, the value of the quantification is the identity of the operator. And the identity of the operator, in this case, summation notation is the same as plus, which is 0.
And I think that would be fine. I mean, I would probably vote for sort of a more formal style, um, like what I did, just because I think it's more precise and less wordy. But if you've already written it out, I would not rewrite it just for that. I think what you've got sounded fine to me.
Okay, thank you.
Other questions?
I was
Um,
wondering if we could like go through an example of a knights and knaves problem because
Sure.
I've just like forgot how to do them a little bit.
I totally understand. And I think there are other people that have probably forgotten. So let me pull up the Knights and Knaves puzzle site that the nice people at University of Hong Kong have provided. Let's see that. No, I don't want to do that. 4 inhabitants would be a lot. Oh, yeah. No, fast forward. Okay. So, yeah, I think this one will be fine. Okay, so I'm going to do, and actually, I'm going to type the question because that'll be faster than watching me handwrite the question. And then we'll switch to handwriting when we sort of do the logic. So, so there's 3 inhabitants, Rex, Joe, and Sally. Rex says that Sally is a knave. Joe tells you that it's not the case that, Rex is a knave. Sally claims neither I nor Rex are knaves. Okay. So that's the statements that the people make. Oh, before I forget, I meant to say something about this at the beginning when we were doing the bookkeeping. I sent solutions, scans of solutions to a bunch of basically the last 4 assignments to people that have turned them in. If you didn't get that and you thought you turned it in, you should definitely let me know so that you get a copy. If you have decided you're just never turning that in and you would like a copy because it might be helpful in the exam, you should definitely let me know. So the intent was to give everybody sort of a key to all the homeworks but I didn't want to give them to people that were still working on some of the more recent assignments, for example. So I didn't send it to the whole class. I sent it to people that had turned in those assignments. So if you want a copy and you didn't get one from chapter 5, 5 and 8, 9A and 9B, any of those, let me know and I will take care of that. Oh, actually, probably not 9B because that was due today, right? I'm now lost. But if I haven't done 9B, I'll do it today. But certainly 5, 5, 8, 5 and 8, and 9A all went out. So if you want one of those and you didn't get it, let me know. Okay. And there, what made me think of it is I know there's some Knights and Knaves stuff on that. So, okay. So Rex says that Sally is a knave. So that we just have R equivals not S. So R equivals is the Rex says. So this is Rex says. And this is Sally is a knave. So whenever somebody says something, then we preface that by them and equivalence, because them being a knight is going to be the same as the thing they said being true. So the fact that Rex said Sally is a knave doesn't mean Sally is a knave. We don't know that. Rex could be lying, but we know Rex said it. So if we find out Rex is a knight, then we know this is true. And if we find that Rex is a knave, we know this is false. So these are, their logical values are equivalent, but that doesn't tell us whether this is true or false unless we know stuff about Rex, which we don't know yet. So questions? And then Joe tells you, so Joe says, it's not the case, not, that Rex is a knave, not R. Have we done this one already? Can't tell. I feel like maybe we have. So this is Joe says, and then this is it's not the case. So it's false that, and then this is Rex is a knave. And again, if you have worked on the Knights and Knaves problem and you're like, I don't know if I did the translation right, feel free to ask, right? Take a picture of it and send it to me on a direct message on Slack or in an email and be like, is this translation right? And I'm happy to look at that and point out, if there are issues. So don't feel like you have to just drift in space on these things. And then Sally claims, so Sally says, neither I nor Rex are knaves. So it's not the case that Sally is a knave or Rex is a knave. Okay. So, and notice that this is sort of I means Sally in this case, because Sally is the speaker. Okay. Questions on any of this? And now, well, we can pretty quickly simplify this to just J equivals R by double negation. So I'm not writing this up very tidily here. I'm just sort of scribbling. The solutions that I sent out sort of are written up not more nicely than what I'm going to end up doing here. And then this one, there's not much we can do about this yet. So we know that R and S are different. We know that J and R are the same. So we better hope something like comes out of this. So if we have S equivals not S or not R, equivals. So we're going to need to use De Morgan to do something about all these negations. And we can either push this negation in, or we could pull these two negations out. I will actually pull out, I think. So if we take De Morgan is, so I'm going to take 347A, 347A, which says not P and Q equivals not P or not Q. And this part matches this part inside the parentheses. We have a not something or a not something. So I'm going to say this is S equivals not S and R. So now this part here is matching that part there. Are you with me? Questions? And then double negation, which is 312. S equivals S and R. Now, there's not much else I can do with this, but notice I know things about R and S up here. So I could replace R with not S using the thing that Rex said. So this is equivalent to, by Rex's statement, oops, that was not very well written. S equivals S and not S. And now S and not S we know to be false by contradiction. And so, see, coming up here, well, equivals by 342. 342. S is false. So S is a knave. And then again, sort of just, I would probably write this up more nicely on the exam, but I can just push through with these two other pieces and say, and R is a knight because we know R and S have to be different. And J is a knight because J and R have to be the same. And that would then complete the problem. Questions about that? Did that help a little?
Yeah, that was exactly what I wanted. Thank you.
Cool. And notice you could, as a sanity check, and since it's a take-home exam and you've got plenty of time, this would not be an irrational thing to do. you could plug all this back in and see if it makes sense, right? So you could say, well, Rex says that Sally is a knave. Well, Rex is supposed to tell the truth, and Sally is a knave, so that's consistent. Joe tells you that it's not the case that Rex is a knave. That's essentially Joe is telling you that Rex is a knight. Rex is a knight, and Joe tells the truth, so Joe would say that. And Sally says, neither I nor Rex are knaves. Well, it's not true that neither of them is a knave, because Sally is a knave. But Sally's a knave, so we expect her to say something that's not true. So that works too. So we could sort of go through and in an Englishy kind of way, check these. But you could also plug in, false for S, true for R, true for J, in this, and in this, and confirm that they all come out to be true as a way of checking that your solution's correct. So one nice thing about these knights and knaves problems is that if you have an answer you think is right, you can check it yourself in a pretty reasonable way. Whereas like the proofs are pretty hard to check yourself. But here you can sort of plug back in and see if you got the right idea. Questions about the knights and knaves problem? Other questions on the exam? Somebody, I think, had a question around the same time Cassie did.
I was wondering, how do you use 8.5 properly?
8.
Or like, can you just explain it a bit?
Yeah, totally.
3.85, my bad.
Oh, 3.8.5. Okay. I was about to say, I don't think 8.5 is even a rule. So 3.8.5. I'm with you. So that is a fair question. So let's see. We're looking at theorem 3.85, which has two flavors. And it's called replace by true. And there's version A, which says P implies E with Z replaced by P. Equivals P implies E with Z replaced by true. And flavor B is very similar. It just says you can have a conjunction tossed in for fun. Equivals Q and P implies E with Z replaced by true. Oh, yeah, that's right. Okay. So I'll talk about both flavors of it. If, for example, so let me check one thing because I don't want to make sure I don't accidentally just do the problem because that would be bad. Nope, we're good. Okay, so let's prove three, 6, 4, which says P implies Q implies R equivals. Actually, is that going to be helpful? Not really. Actually, this is a bad choice. Sorry. Let's back up. Let's do instead This is going to be kind of a dumb one, but yeah, it'll work. So let's do 376A instead. So our friend weakening strengthening that we have seen many times, which says P, oh, I was supposed to do 376A here. And P implies P or Q, proof. So P implies P or Q. So this is the E with Z replaced by P. And all this means is we have an expression that has a P in it, maybe multiple P's in it, maybe lots of P's in it, but it presumably has a P in it. If it doesn't have one, this is all kind of like unhelpful and doesn't get us anywhere. So we're saying we've got P implies some expression that has P in it, and then we can say that is by 385A P implies, and now we take this expression and instead of Z being P, Z becomes true. So this is telling us we can replace any or all of the P's with trues. Well, there's only one P in this case, so I'll say true or Q. Okay. And then now we just use some other chapter 3 rules. So true or Q is true by 329. And P implies true holds by 372. So we would be done by 372. Okay. Does that make sense? Questions about that little proof?
That helped. Thank you.
And the central idea, if you think about it, this is saying that P implies something. We're sort of assume that this is true, then show that this is true. So if the thing we're assuming is just a letter, what does it mean to assume it? Well, one of the things that it means to assume it is we could replace all of the occurrences of that letter with true. And so this implication only makes sense if the right-hand side works, if we put true in for P. Because if P is false, this implication, right, if P is false here, this implication is true because false implies anything. So we don't really care about the false case for P. The only case for P that matters to us in an interesting way is the true case. So we sort of assume that it's true. And if we're going to assume that it's true, then let's just put true in for all the P's. And that often allows us to simplify down expressions in useful ways, okay? Like in this case, by putting a true in here, the right-hand side collapsed down to just true, and then we could be like, done by a rule, okay? And the Q version B here is the same thing. It allows us to use situations where we've got more than just P on the left-hand side. We know P and some other stuff is true, then we can assume P at least is true and have the other stuff kind of hanging around. So as an example, if I wanted to prove, let me check one thing. Yeah, I don't want to do that one. If I wanted to do so there's one in the book, not in a theorem that's not in the book, that's in the big list of theorems, which they call 3.76.1, and it says P and Q implies P or R. And we can prove that using 385b. So P and Q implies P or R equivals by 385b. P and Q implies true or R. So because we know P is true over here in this and, we can replace it with true over here. And now essentially the same thing's going to happen, right? We get 329 collapses that right-hand side to true. And we know anything implies true by 327, and we're done. Or 372, sorry. Okay. So questions about that? And I think those Leibniz's axiom rules from 383 to 389 are kind of weird that way. People are often a little confused as to what they can do with them, or how to use them effectively. And it's usually some version of this, that there's, something, and especially the replace by, so 385 through 388, all of those, you're allowed to replace something somewhere by either true or false in a way that's hopefully useful and let you, collapse things down. 383 and 384 are more general, and can be used in a broader range of circumstances, but the replace ones actually come up a fair bit in certain kinds of logic proofs, and can be useful in a way that's very similar to what we did in these two examples. And then one other one here that we haven't talked about a lot, and actually I came very close to having an exam question about it, but I couldn't come up with something I particularly liked. So 389 Shannon, so it's named after a mathematician, logician, Claude Shannon, who did a lot of important work in information theory in the 1950s. And Shannon says E with Z replaced by P equivals P and E Z replaced by true, or not P and E with Z replaced by false. And so this is basically letting us split things into cases. So if we're trying to prove something and we're just hopelessly stuck, one option would be to say, well, we know P is either true or false, so let's break it up into pieces. And Shannon would let you do that. So if we had, I don't know, to take an example. So this is another thing that's not in the book, but is in the big printed list of theorems. 3822 says P equivals Q implies P implies Q. And if we were just really lost for something to do here, one option would be, and I don't typically recommend this. I mean, this should be an action of last resort, not first thing you do, because it tends to make long, unattractive proofs. But it will almost always get you somewhere if you're otherwise completely stuck. So we could say P equivals Q implies P implies Q is by Shannon, 389. Now this part's going to get really big and ugly. So we'd have P and this whole thing with all the P's replaced by trues. So we're going to have true equivals Q implies true implies Q, or not P and this whole thing with P replaced by false. So false equivals Q implies false implies Q. And so, like, this is a pretty good example of why this isn't actually a great tool unless you're really, really stuck, because we can see this has made this a lot longer. This is now a big, ugly thing. But on the other hand, a lot of things are going to collapse now. So I probably won't go through the whole thing, but we'd have P, and so true equivals Q is going to just be Q, and true implies Q is going to be Q, or not P, and false equivals Q is not Q, implies Q is true, and this will be true by 371, and this is true by 372, and so those will both become true, and then you'll have P and true is P, and not P and true is not P, and so it'll all simplify down to P or not P, and that's true by excluded middle, and then you would be done. So there's a few steps still to do, but you could sort of push this through, and everything from here forward is in some sense pretty mechanical, right? It's like just taking advantage of these simplifications and then just grinding your way through till you get to the end. It's got no elegance to it at all. It is a bulldozer, and there's very little subtlety here, but it does work. So if you're really in a pinch, right, you could always, just throw a hand grenade at the problem and hope that you can, get through it that way. But yeah, so, and this is part of why I ended up not doing one on the test. I couldn't come up with an example that didn't end up feeling like I was just asking you to like beat something with a crowbar until it gave up, and that I didn't like that lack of elegance at all. It seemed just very crude, so I didn't do it. So that was a long answer. I hope that was okay. Questions about any of that, or a question moving forward?
I'm still shaky on the translating from English to logic, the chapter 9 logic translations. So
As is everybody. So as a heads up, or I don't know what the right word there is, the problem on the exam is specifically intended to be fairly simple, right? There are like some pretty nasty problems. Well, nasty is the wrong word. There are much harder problems in the book. So I deliberately tried to not make that one, the one on the exam, a particularly difficult one. But is there a problem in the book or a kind of problem from the book that you would like to talk about that would be helpful on this front?
Oh no, I'm not too sure because I was still sketchy from Friday's viewing, so I don't know. I guess maybe I'm thinking ahead for like the assignment, but
Well, and so so there's the part B assignment, which is the translating from English to logic. And that's what we talked about on Friday. There's also the part C assignment that I just moved because we haven't even done any examples of that. And so if there were time today, that's where I would go, is to doing the logic to English. But I'm happy to talk about the English to logic. It would just be useful to have like something specific, like if you wanted to pick a problem.
no, I was talking about like first part C. So if you
Oh,
haven't
the
done
part C. Oh, okay, totally.
good.
Yeah, no,
that's
that
good.
I definitely, that's where I was headed next. So is there anybody that has a question about the exam before we kind of move past the exam into the homework? Because I'd want to give you a chance to ask exam related questions first. Not hearing any. Then let us contemplate some of the logic to English. These, as much as everybody loved the English to logic, the logic to English are worse, I think. In particular, I think it's worse if you try to come up with a kind of an English translation that flows and sounds like English and not just like a brute force translation of the logic. So let me, so we got 9 minutes. Let's do 930C. Which says for all x in R, x differs from M, f of x greater than f of M. Okay. Now, what I often find helpful for these is actually drawing a graph, especially the ones that are like mathy, which is basically most everything in 9.30 looks like it came from a pre-calc class or a calculus class. And so I find that a graph is often more useful here as a way to just think about what this means, and then we can tidy things up and turn it into English after I feel like I sort of get it. So if I have x and f of x, now if I look at this, f of m seems to be important. Like m's an important value here. It's not being quantified over, it's coming in from the outside, as it were. And we're saying that when x is different from m, f of x is bigger than f of m. So if we just sort of pick in my picture m, and we say this is f of m, okay, then what does that tell us? If this is, if I say like, this is a, what do we know about f of a, given this quantification here? Anybody?
It's greater than f of m.
Yeah, it's got to be bigger than f of m. So if I think of f of m, if I sort of draw myself a little line, dotted line here, right? F of a has to be somewhere up here. It can't be down below, right? And if this is f of b has to also be up here somewhere. And if this is f of c has to be up here somewhere. So for all other values, f has to be above this line, right? It's got to be up here somewhere. It can't ever be below there. Does that make sense? So a way to say this in English is that this is the smallest value that f ever takes. That f of m, its minimum value is f of m. Okay? That f of anything is bigger than that. So we could say f of m is the minimal value of f. That would be sort of a nice Englishy way of answering that question, versus sort of a more sort of brute force translation, which is what the book's trying to get you to not do when they say, don't simply make a literal translation, try instead to extract the meaning of each formula and express that as you would in English. So the thing they're kind of trying to get you to avoid is to say, for all real x such that x is not equal to m, f of x greater than f of m. Like, that's true. That is a translation of this quantifier, but it doesn't really tell us anything that the quantifier didn't tell us, right? Looking at it doesn't yield any useful information. If we were to walk up to somebody and say this, they would think we were total math nerds. And it wouldn't necessarily mean something to them. Whereas if we say that f of m is the minimal or smallest value of f, right, that would make a little more sense to some people. I wouldn't go so far as say it would make sense to everybody, but it'd make a little more sense to some people, okay? So I find it useful to draw pictures like this and then use that to help me figure out, well, what does this actually mean in a graphical sense, and then try to convert that, what I sort of understand from the picture, into English instead of trying to go straight from here, because I think going from the logic straight to the English is actually pretty difficult. You tend to end up down with these sorts of, brute force translations. But that if I can draw a nice picture, I can often sort of extract a piece of English from it that makes some sense. Questions about that? Going. Let's see, we have 2 minutes left. Do I think I could do another example in 2 minutes? Probably not. So we can do more of these on Wednesday after we're done with questions on the exam. But I'm happy to, if somebody's got a quick question on the exam or a quick question about anything else, definitely let me know. I'd be happy to take that now.
Can you explain the graph again there that you drew?
Yeah, so I'm just saying, like, I have x as my x-axis and f of x will be my y-axis. And I think the most important part of this, in some ways, is recognizing that m is sort of coming in from the outside. Like, it's not quantified over, so it's being handed to us in some fashion. So we're saying, so m has a special role here, because it's being given to us as a particular value. So I'm gonna say, well, okay, if this is m, then I got to pick a value, f of m, could be down here, could be up there, it doesn't matter. Pick a value, And now I want to think about, well, this says for all x, some stuff is true. What does that mean? Well, if I say A is a possible x, and it's different from M, what does this tell me? Well, as Justin said, it tells me that f of A is bigger than f of M. So I don't know what the actual value of f of A is, but I know it's up here somewhere. It's above this little dashed line. And I know that f of B is above that dashed line and f of C is above that dashed line. So whatever f is, I know it's got to be above that dashed line, except for when x is equal to C. So I don't know what f looks like, but I know it's got to stay up here, except it touches there, and then it, you know, wanders on indefinitely, does whatever it does, but it's always above this line, right? So that this is the smallest value it can ever take. And that would be true going to the left as well. Right? That's clearly not a function. We've lost functionness pretty seriously there, but whatever. So whatever f does, it never goes below this dotted line. And it only reaches the dotted line when x is equal to m. So we know f of m is the value of f of m. And so it reaches the line there. And everywhere else, it's strictly bigger than that. So it never touches the line anywhere else. And then that is sort of what leads me to this piece of English. And it's super fuzzy, and I get that that's super fuzzy, and this is why everybody really, really, really doesn't like these problems very much. But, you know, I think it's important to be able to think about what quantifications like this mean in English, and so it's you know, good to wrestle with a few of them. So, did that help some? Excuse me.
Yeah, that did.
Okay. We have -1 minutes left. Anybody got a quick question, or should I let everybody go? Okay, so homework has been pushed off. Exam is due Thursday, so definitely be working on that. Wednesday, we can spend as much time answering questions as you want. Feel free to sign up for a office hour slot. Feel free to email me or use Slack to ask questions. I've been taking a number of questions there over the weekend. Otherwise, I will see you in a couple of days. So wash your hands and stay safe. Ciao.